The Urey-Miller experiments were recognized as an important breakthrough in the study of the origin of life. During 1953, Harold Urey student Stanley Miller recreated conditions during early Earth, the Hayden Earth, to see if living things could exist during that time. Before this experiment, Urey calculated the components in the atmosphere of early Earth during 1952. He found that the main components in the atmosphere back then were methane, ammonia, hydrogen, and water. Next, Urey suggested Miller should try and simulate the ancient water cycle. With Urey's help, Miller built the apparatus. He added water to the apparatus and boiled it to simulate evaporation. A condenser allowed water to precipitate, simulating rain. He then passed a continuous spark that simulated lightning through a flask containing methane, hydrogen, ammonia, and as well as water at a discharge of 60,000 volts. After a week, he found that most of the ammonia and methane was used up, and that carbon monoxide and nitrogen were produced. He also saw some dark material in the water. After analysing the solution, he found that the solution contained 22 amino acids. 13 of these amino acids could be used to make proteins in living cells. Previously, scientists thought that amino acids could only be built inside living organisms. The experiment proved that organic compounds, the key molecules of life, could be synthesized from inorganic substances. However, there has been recent doubt about their experiments. For example, there is geological evidence that early Earth was an oxygen-rich, oxidizing atmosphere and didn't contain free hydrogen. Urey made his calculations about the components of the early atmosphere, thinking the early atmosphere was reducing, meaning he thought it contained free hydrogen. On the other hand, there is also evidence from 2005 that the early atmosphere of Earth could have contained up to 40% hydrogen. Other criticisms of the experiment include that there weren't continuous lightning storms during primitive Earth, so there may not have been as many amino acids and organic compounds formed as Urey and Miller had thought, as well as that organic molecules could have come from meteorites and comets. The debate is ongoing. Although scientists continue to discover more evidence against the Urey-Miller experiment when uncovering the composition of the atmosphere of primitive Earth, the experiment still remains significant in the advancement of ideas on the composition of ancient Earth.
Created using Powtoon.